All right, let's do another one. Suppose we have 50 grams of tetraphosphorus digoxide and 500 grams of water, and we want to put those together to react to make phosphoric acid. Let's see how much phosphoric acid we can make in grams. So first things first, you'll want to balance the equation. And I would again suggest pausing the video and doing it. So go ahead, pause it, and then look at the answer. So here we should get 6 and 4 as our coefficients. And so that'll be our balanced equation there. And of course 1 for the phosphorus. So with any limiting reactant problem, you're going to want to do the stoichiometry for each component. So for the phosphorus containing one, well, we can do that. 50 grams P4O10. We're going to avoid using the I delta F table right now because the moles we don't have directly. So we're just going to do the stoichiometry. We're going to have to figure out its molar mass. So let's look up the atomic mass of phosphorus. It is 30.97. I'm going to put that in my calculator, times 4 plus 10 times 16. All right, so we've got that. Oops. So our molar mass is 283.88 grams for 1 mole. And since we're interested in seeing how much product, we'll go ahead and use that as our the thing we're looking for. So here we're going to have 1 mole of our P4O10. This is our reaction coefficients now. 4 moles of phosphoric acid. And now we need the molar mass of the phosphoric acid. Note, a lot of students put a 4 with this. We don't do that. Molar mass is constant for each compound. Does not matter what the coefficient is. For example, water's molar mass is 18.02. It is never 6 times 18.02. The 6 is taken care of elsewhere in our math. So do not include coefficients when you're determining molar mass of a compound. So the phosphorus here, we have 30.97 plus 4 oxygens, 4 times 16, plus 3 times 1.008. That is our phosphoric acid molar mass. We have 97.994 grams per mole of phosphoric acid. Out of space here, but that's okay. Let's go ahead and do the math. So we're going to have 50 divided by 283.88 times 4 times 97.994. We get 69.04, we'll say. And we'll just go ahead and indicate that we have only 3 sig figs here. Let's just keep it for now, just in case we have a problem. All right, so that's the amount we can make with our phosphorus-containing compound, our P4O10. All right, we now have to do the same thing with water, using 500 grams instead. So, thankfully for us, all of this is going to be the same at the end, except for that 1 on the bottom, but we'll deal with that. So, we have 500 grams of water, I think with only 3 sig figs again. Our molar mass of water for 1 mole of water is 18.02 grams. Don't use the 6, don't put the coefficient there, because the coefficient comes right here in the next part. Get rid of one of these x's. Aha! I'm cheating and reusing my work. Okay, we have 6 moles of water on the bottom, and then we have the rest of it is identical to what it was before. So, doing the math, 500 divided by 18.02 times 4 over 6 times 97.994 is 1,812.689, whatever. We have a lot of numbers. We don't need them. We only have 3 sig figs here. So hopefully we'll see one of these reactants will run out a lot sooner. And indeed, that is the P4O10. So we're going to see that this number here is the amount of phosphoric acid we can make. We call this number our theoretical yield of phosphoric acid. That's the lower number. That's the amount we can possibly make. We cannot make any more than this. And with sig figs, we'll go ahead and remove that 4. We'll make 69.0 grams. And that's our theoretical yield. And so if we were so inclined to figure out how much water is left over, we could do that. And since we have grams this time, it's a little bit easier to use the fraction method of determining this. So if we have 69 over 1812.7, again, I'm not going to worry about sig figs here. We know we're going to have 3. So I'm still going to put in all the numbers that we have just to try and keep that accuracy. We're going to multiply that by our original 500 grams of water. And we can see how much water we used up. So 69.04 divided by that number that we just calculated times 500 grams. We have used up 19.04 grams of water. And so if we want to figure out how much is left over, that would be 500, our initial amount, minus 19 grams is going to be 481 grams of water, left over. So if we're so interested in that. So we have this much water left over, we have this much phosphoric acid, and we will have none of our P4O10 left, because that has all been used up. So when you have a limiting reactant, you're going to use all of it. You'll have an excess reactant that you can calculate the amount left over, as well as the amount used, depending on whatever you're interested in looking for, whatever the question's asking you. And so with this, hopefully this is another example you can use in practicing your skills. Again, I would recommend practicing this very heavily because this is a skill that we're going to be using throughout the semester. In our next video, the final one for this chapter, we'll discuss reaction yields and how real life can sometimes mess up our theoretical yield.